We often imagine human memory as a vast collection of files, where every experience is written down and tucked away for safekeeping. The reality is biological. Every moment you live causes neurons to fire in specific patterns, building a physical bridge called a synapse. Your amygdala oversees this construction, attaching a chemical tag to these bridges, labeling them with fear, joy, or pain. Because memories are physical structures, the intensity of the emotion acts like a stabilizer. The stronger the feeling, the more fortified the neural connection becomes. With millions of these connections forming daily, the brain has to determine which structures to maintain and which to dismantle. The hippocampus serves as the priority sorting system, preserving the memories that are most relevant to your basic survival and safety. During a traumatic event, a flood of stress hormones like cortisol and adrenaline reinforces the synaptic structure, creating a memory designed to be permanent. This raises a question about the nature of healing. If painful memories are hardened physical objects, how can we ever move past them? While we say that time heals all wounds, the brain is doing the work of actively altering these physical structures to make that possible. The process begins with the act of remembering itself. When you recall an event, the brain does not play back a recording, it reconstructs the memory from scratch. This reconstruction has a biological cost. Bringing a memory out of storage makes its physical structure unstable and vulnerable to change. This is the reconsolidation window. It is a brief period where the brain modifies the memory before saving it again. During this window, the brain monitors for new stress signals. If you recall a memory without a fresh surge of cortisol, your brain cells begin removing AMPA receptors, the specialized protein anchors that maintain the strength of the connection. This removal weakens the physical bridge, causing the associated pain to shrink. Every time you recall a painful memory without fresh trauma, the brain uses reconsolidation to overwrite the old structure with a slightly less painful version. The brain prioritizes this work during REM sleep, replaying emotional memories, while norepinephrine, the chemical that amplifies stress, drops to near zero. In this low-stress environment, the brain processes the events of the day without the original emotional reaction, detoxifying the memory overnight. Clinical research into behavioral updating suggests we can also exploit this biological window through therapy. Using a technique called mismatch, a therapist triggers a specific memory to make it unstable, then introduces a safe or contradictory experience. This rewrites the synaptic connection before it has a chance to reconsolidate. Through the natural mechanism of sleep or targeted therapeutic intervention, the brain possesses a biological process designed to unlearn emotional pain. However, severe trauma can cause this natural updating loop to break down. In cases of PTSD, the initial experience is so overwhelming that it disrupts the brain's normal reconsolidation cycle. Research indicates traumatic memories are represented differently in the brain. Instead of being filed by the hippocampus, they bypass standard processing to trigger an immediate neural alarm system. This alternative routing causes them to be experienced as intrusive, present-tense threats caught in an inescapable loop. PTSD represents a mechanical failure of the brain's natural reconsolidation cycle, rather than an emotional struggle. The fading of an emotional memory reflects an active biological process. It is the result of the mind prioritizing and rewriting its own architecture. Forgetting is entirely intentional. It allows the brain to prune unnecessary information while keeping core survival lessons intact. The brain updates these memories to free us, using reconsolidation as an evolutionary tool, so we can learn from our most painful moments without being permanently trapped inside them.